Hi friends, in this video we are going to look at how we can incorporate a button so that when we press the button an LED turns on, when we unpress the button an LED turns off. The video that you are seeing here, or rather the simulation you are seeing here, is our previous simulation which we managed to program an LED so that it can be blinking every after 250 milliseconds, that's quarter a second. So let me pause the simulation and we go back to the code. So this is the code that we wrote, which was switching on the LED for 250 milliseconds, turn it off for another 200 milliseconds, and that's the blinking you are seeing. But this time around we want to see how we can incorporate a button in such a way that when we press the button an LED turns on, when we unpress the button an LED turns off. So let's go to the simulation. We add the button. So here I'm going to pick the button from the library, pick parts. Now I'm interested in the button, so get the button. Okay, just type button like that. Okay, so we are going to hook it to pin 4. Okay, doesn't matter, you can use any digital pin. Then we connect it to the ground and this one to pin 4. So I have to mention to you that this button, the way it works, in its off state, when it's not pressed, there's a 5 volts at this particular point. So meaning the microcontroller will see a 5 volts appearing at this particular point. That is, the pin 4 will be at will have 5 volts. If I press the button, because there is a ground here, okay, there's a ground here, so meaning the difference between this ground and that particular ground should be 0 volts. So meaning if ground is 0 volts, as we know, meaning we are going to have another 0 volts here. So in logic we would say if I press the button there will be a logic 0 here. If I unplace the button there will be a logic 1. So now we know how this button works. So let's go and now write the code. Okay, so we are going to just change a few things to our already existing code which we wrote for the blinking. So let me just remove this comment and the delay. We are no longer now interested in the delay. Okay, so even this delay, remove it. Okay, the turning on and off, we need them. So even here, let's just remove the comments. Okay, those are just comments. So we are going now to include another variable which we call int for integer, and we call it button. And because we want it to be on pin 4, so we equate it to pin 4. So button equal to pin 4. Like I said, what this just means is that wherever there is a button is as good as typing a 4. Okay, so we'll come now here in pin mode. Okay, I'll just copy this, Control C, and paste it, which is Control V. Okay, so now we need to configure. Like I told you, the first thing that you need to do when you want to use the pin of the microcontroller, you have to configure it. You have to tell the microcontroller if that will be an input or output. So we want this to be an input, so we type button, which is an input now. So we type input. Okay, input like this. Okay, like that. So this is how it is. So now we go into the loop function. So in the loop function we are going to use the if condition. So if it's a condition which it will execute the, okay, let me write the syntax. So it's if you put a condition in the bracket. Okay, if condition, then it will do some tasks. So in this case we want it to turn on the LED. So okay, so it's if, so we must put a condition here. Okay, if we put a condition, then it will do this, else we are going to see what it will do. So we use the if else statement. So if this condition is true, which we are going to put inside these brackets, if it's true, it will do this, it will turn on, else it will turn off an LED. So what we want is now we are going to introduce another new instruction here, which is called a digital read, where we have to read the state of the button. So we just type digital read, okay, like that. So you have to specify which pin you want to read. It only takes one parameter, which is the button. In this case, you don't specify two things, no, it's just one, because you're just reading there. Okay, so say Control C, that's copy, then Control V, that's paste. Okay, so if we read this, okay, which is the button, and if the after the microcontroller will read this, the button, the state of the button, so we are going to compare it. So if this button is equal to low, because we know that when we press that button it will be low, so if it's low, then it will do this, else, okay, else simply means if that is not low, meaning it will be high, it will just do the following, which is else we just expect it to do the other part, turning it off, just like this. So I'll go through again. So we have configured button as an input, okay, and as an input pin, so meaning the microcontroller will be reading this pin, and depending on the status of the pin, we can either perform the digital write or the digital write high or the digital write low, that is turning on or turning off. So if the button is low, then the LED will be turned high or to be switched on, otherwise, which is else, it will be switched low. So let's go and verify this. We can just go direct to Sketch and export like we did in these other two videos. So wait for it to compile and generate the Excel file. Okay, so it's compiling. Okay, it's compiling. We wait. Okay, and it's done compiling. Okay, it's done compiling. We can now go back to the Proteus simulator. We double click on this one, then we go on this. Okay, so we can just check time. Okay, that's 14:43. Okay, so like that. Okay, we try to run the code. Okay, wow, I haven't pressed the button, but the LED has turned on, but we said no, we want it to turn on when I press the button. Wow, what's happening here? Okay, we press the button again, doesn't change, still on, and press the button, it goes off. Press it again, it goes on, and press, it goes off. Wait, let's pause stop the simulation. Okay, stop the simulation, then we run again. Wow, look at this. When we just run for the first time, the LED is on. When I press the button, it seems like it's not executing the program that we've written here, not until and press it back, then it starts working perfectly. What could be the problem? Okay, so let's go back to the code. Okay, before I go back to the code, I have to mention to you to say, like I said, the way this button works, like the way it is, when it's not pressed, there is a 5 volts appeared in there. Okay, so when we come to the code, let me pause the simulation. When we come to the code now, the one which we've written, okay, we are saying pin mode button input. So in this state, we are not telling the microcontroller that particular pin, actually there's a 5 volts by default, meaning in that state of the switch, there's a 5 volts present there. We call this as pull up. Okay, so even the microcontroller, the internal register, must also be aware that that pin is at logic 5. So how do you now rectify that error? All you just have to do, you have to now write not only the input, but we should say input pull up, input pull up. So, and this should be in capital. Okay, input pull up. Okay, yeah, what this simply means that you are telling the microcontroller to say, oh my dear, that particular pin by default it's at high volt, it's at 5 volts. So we should also make sure that even the internal register of the microcontroller is also aware, or it's also at 5 volts, so that the outside world and the inside world, now they are synchronized, they are working at the same state, that is 5 volts, 5 volts. So let's try to go to sketch and export compiled binary and see. So it's now compiling and execute, rather generating the exa file. Okay, so let's wait for it. Okay, we wait for it and we go back to the simulator, this one, click on that one, then we upload. Okay, let's upload it again. Okay, and let's test it now. So this time around we expect it to be off because the switch isn't pressed. Okay, let's run it. Wow, the simulation is working, the LED is off. Let's try to press the button. Press the button. Wow, it goes on, and press the button. Cool, this is what we wanted this to happen, and it is done. So what have we learned? We've learned that whenever you are using this type of a button, which is logic high by default, you must tell the microcontroller to say, oh my dear, the button is by default high. So yeah, that's how you actually rectify that simple problem. Yeah, this, in most students, they forget this particular point. It's very important to note whenever you're dealing with this type of microcontroller. Please, 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 you have to understand the pull up resistor. Okay, thank you very much for your time. If you like the video, please click the like button. If you don't like the video, do as wise, click the unlike button, and see you soon.